Okay, so here's the video for the Pear Deck for today, uh, April 19. So I went ahead and did that the domain or the X values um, for the time for minutes. Let me see. Got label it too. So this is times in time in minutes. And I went by three, so 3, 6, 9, 12, 15. And then over here we have temperature, and this can be in Fahrenheit. And leave it like that, just. And so there are our points, and what we need to do, we created a scatter plot and label our axis. So let's go ahead and do temperature over here. Wonder if we can temperature, and we'll do temperature, and then I think I can scoot it like this, and we're gonna drag it. So we're gonna do like this. Okay, perfect. Okay, use technology to write the exponential regression equation, define the variables, identify the correlation coefficient. Okay, so we're gonna use Desmos graphing calculator. So let me open that. That's not what I want. Let's see, Desmos graphing calculator. There we go. Okay, so we're gonna do the plus sign, then we're gonna do the table, and then we're going to plot those points. So even if it's 0, we still want to plot that point. Okay, so we got 0, 5, 0, 5, 11, 15, 18, 25, 30, 34, 42, 45, and 50. And then we're going to do 180, 169, 149, 142, 135, 124, 116, 113, 106, 102, and 101. Okay. And then we can take a look to see where they are. There they are. Okay. And click on the second line. And we're going to do Y sub 1. We want to do this similar. So go to ABC. Let me move this to the top. ABC, this quickly line right here. And we got A times B to the X power. X1. So here is the line that best fits our model. Okay. So there's the equation. So we have y. We can do as a function. This is y as a function. Let's see. Do we want as a function? Just doing to write the equation. They say equation. So let's go. Y is equal to 174.856 times b, which is 0.987611 to the x power. Okay, so there's the equation. So x is time, and y is the temperature. Okay, so let's see. Use technology to write the exponential regression equation. So the equation is y equals 174.856 times 0.987611 to the x power. Okay, so use technology to write the exponential regression equation, define the variables. So y is temperature and x is time. And identify the correlation coefficient. The correlation coefficient is going to be for exponential function, it's going to be this r squared. So we're going to go r to the second power is 0.9736. So r squared is equal to 0.9736. Model this situation, sketch the function of the same graph as your scattered plot. So, okay, so let's go ahead and that's laying the line a little too thick. Mhm. Okay. So basically what we want is we want that graph right there. So we're just gonna go ahead and sketch exponential function. That's it. State the domain and range of the function you sketch. How do this compare to the domain and range of this problem situation? Okay, so for the domain, so for the function, the domain is all real numbers. Okay. The range is y is greater than 0. That looks like to be our horizontal asymptote. So all the numbers greater than 0. Okay, so that's kind of like for the real for the mathematical way. Now for the problem situation, so for the problem, our domain is going to be, well, let's see how hot it is and how cold it's going to be. So it starts from 180 and it goes all the way to 101. So from 180 to 101 or from 101 to 180. So domain is 101 less than x less than 180. And it could be less than or equal to, since it does get to those points. So less than or equal to x and less than to 101, less than or equal to x, less than or equal to 180. Okay, the range, well, where do we start with our, actually, I think I made a mistake. The domain is from 0 to 50, my bad. So from 0 to 50, because that is our x. Okay, from 0 to 50, and our range is from 101 to 180. So 101 less than or equal to y and less than or equal to 180. Okay, use the equation to predict the temperature of Caroline T after an hour. So let's go back. So what will be the temperature for her after 1 hour? So after 1 hour will be 60 minutes. Well, this is pretty, let's see, pretty simple. I think we can type in 60 right here and see what that, oh, it won't give us the number for this. Okay, so let's type it in on the equation then. So the x would be to the 60th power. So it would be that. So pretty simple. You just type it in the time that you want, and it's gonna give you so 60 hours. The temperature is gonna be 82.763. 82 point. What was it? 82.76. Are we running? What are we running to? Let's just keep it like this. Okay. 82.76. Use the equation to predict temperature quality after 4 hours. So 4 hours. So I'm not typing four, just so we know, because it's and X represents minutes. So let's see, 174.856 and 0.987611. And so 4 hours, let's change that into minutes. So 4 hours would be 64 times 6 is 24, so it'll be 240. So it'll be 8.77. Does your prediction make sense in terms of this problem situation? It doesn't make sense unless you were like in a place like it was like super freeze cold, where the temperature would actually get that cold. Okay, so if it's room temperature, I'm not really sure what the temperature would be for. Well, it would be like 70 degrees. So that's kind of like where the water would kind of like starts labeling out. So so it doesn't make sense unless you put the tea in the freezer, and I don't think that was the point. So uh, it does not make sense unless you are putting the tea in the freezer. Okay. Now, this is actually pretty good for people that are, like want to learn about like how they figure out. Um, I don't know. Maybe we'll get to it. Like the people that work like in with police, and they want to find out how long this body has been dead, because the body temperature it cools down after you die. So you can actually figure out how many hours has it been since this person has died. So it's a little bit useful for some of you that might be interested in working like that. Okay, so let's go to transom, and like I said, I'm going to do like one of each. So find the amount of interest accrued. So here we only want interest. So we're going to go 240. So it's going to be A is equal to the principal times 1 plus the rate. Remember the rate divided by 100 to the T power or X power. And in this case, since we only want the interest, okay, we're going to subtract how much money we start with. Okay. So we start with 240. Okay. And then 1 plus 1 divided by 100 to the eighth power, and then minus the 240. Okay, and that's because we're only interested on that. We're only interested in the interest. So let's go ahead and use Desmos. So let's see, Desmos. If you go here, I don't know. Somebody actually did like a decimals. Guess it could be decimals right here. Okay, so decimals, and then just go to a graphing calculator, scientific calculator. Okay, so we got 240 parentheses 1 plus 1 divided by 100 raised to the eighth power, but we don't want the 240, so minus the 240. So that gives us 19.885. Since that number is a 5, that means we're going to have to round out to 19.89. Okay. Next one, find the total amount of payment requirement. So this time, for this one, we are not going to subtract the original amount because we want the whole amount. Okay. Find the total amount. So we're going to go 340. Let's see, 340, 3 and 7. So 340, 3 and 7. And this time we do not subtract the original amount. So for 18.157, because that 7 is greater than 5, that means this 5 is going to turn into a 6. So I'm going to copy and paste it like this, and then I'm going to change it. Okay. Let's see. What percentage is the total interest accrued of the original loan? Okay. So this one, what we're going to do is we're going to figure out how much money you've earned, and then divide it by our original amount. So we're going to go 470, 1 plus 5 divided by 100 to the ninth power, divided by the original amount, which is the 470. Now, this that it only, not only gives us a percent, but also gives us like our original amount. So what we gotta do is we gotta subtract 1 because that represents our original amount. So it will just be 0.5513. We want it as a percent, so it'll be 55.13%. So 55.13%. Okay. And last ones, how many years would it take for you to be 233.97 in debt after 200 is borrowed with a 4% interest compound? So for this one, we're not going to use the scientific calculator. We're going to use the decimals graphing calculator because we're going to give you, we're going to go like two graphs and see where they intersect. Okay. So let's see. Okay. So we're going to go y is equal to 233.97, 1 plus 4 divided by 100, okay, raised to the fourth power. Okay, so there's the equation. And we want to know when are we going to have, okay, let me, sorry. We start with 200 and we want to know when are we going to get to when y is equal to 233.97. Okay, so there's two ways to do it. One of them is you can just take a look and see where the lines intersect. I thought it was 4 years. Never mind. X power. So you see where they intersect. Let's zoom in. Make sure you zoom in. And there it is. After 4 years. Oh, it is good for you. 4 years. You get 233.97. The other way you can do it is if you click here and you do the table, you keep on going till you get to 233.97. So that's 2, 3, 4, and there it is, 233.97. Type in 4. Check it, and we got it. Okay, so I did one of each. Now you guys just gotta finish the rest of them. Level 4, um, it's kind of like the same thing it's the same thing we've been doing. So a house is bought for $469,000. In each of the 8 years to follow, its value appreciates. Okay, so if appreciates is going to be increasing. So appreciates means you're going to be adding the percent. Depreciates, that means you're going to be losing the percent. So appreciate, you're going to be adding, depreciating is going to be subtracting. Okay. So go ahead and give it a shot. Try them. Okay. Um, Pretty much it's like the ones we just did. Mhm. I'll give you the answer for one of them. This one comes out to be after 29 years, and I think it's the same for everybody. So give it a shot. See what you guys how you guys do.